is the review for the pre-calculus chapter 7. And, so there's some vocabulary. So I'm going to set it the way I want it. There we go. There's some vocabulary. And it'll be slightly different on the test, of course. The number of degrees in one revolution is 360 degrees. If it's asked for the number of radians in one revolution, it would be 2 pi radians. The range of the sine function, with no -1 is less than or equal to y, is less than or equal to 1, between -1 and 1. The cotangent function has a period of pi, and the sine and cosine functions are both negative in the third quadrant. 224, change it to, or 225, change that to radians. 25 over 1 times pi over 180. With radians, there needs to be a pi. So it's going to be a numerator. 225 over 180 is 5/4. So this is 5 pi over 4. And then we have 11 pi over, what I was going to say is that 225 is an angle we know. 225 degrees is this one. And so if this is 4 pi over 4, then that's all the way from here to here is 5 pi over 4. And that's what I was going to say. And I could do this one the same way. 11 pi over 6, that's an angle we do know. 11 pi over 6 is over here. And this is 12 pi over 6. So 11 pi over 6 is one back from that. And 11 pi over 6 degrees all the way around. This is a 30-degree angle, so it would be 330 degrees. Which is 5 pi over 4. 330 degrees. Now, on the test, it could very well be that you're not going to recognize the angles. It's not going to be an angle we know. And so, mathematically, I would take this times 180 over pi. So, the pi's cancel, and then 6 goes into 180 30 times. 30 times 11 is 330. Next one, sector of a circle. So the sector of a circle, the length of the sector formula is S equals R theta. And the area formula is K equals 1/2 RS. So the sector has a radius of 8 and a central angle of 3 radians. And remember, for either of these formulas, the angle has to be in radians. So if it's not, you either change it to radians, or if it is, then you leave it alone. So S is going to be the radius, which is 8, times the angle theta, which is 3. So S is 24 centimeters. And put centimeters on that. Okay. And then the area is 1/2 the radius, which is 8, times S, which is 24. So we get half of 24 is 12. 12 times 8 is 96 centimeters squared, the area of that sector. And give the exact value. So 5 pi over 6. 5 pi over 6 would be in the second quadrant. That would be a 30-degree angle. So this is 1, 2, square root 3 sign is positive in that quadrant, so 1/2. Negative 300. Go to a piece of scratch paper here, finding that the cosecant of negative 300. So negative 300 is actually going to be all the way back to this first quadrant. And this is negative 300, so this is 60-degree reference angle. And the 1 would be here, the 2 would be here, the square root of 3 would be here. And cosecant is the reciprocal of the sine, so the sine of that angle would be the square root of 3 over 2. Cosecant would be 2 over the square root of 3. And positive in the first quadrant. We have the cosine of negative 135 degrees. So 10. So that negative 135 is going to put us in the third quadrant. Here, that would be negative 135. We always draw our triangle to the x-axis. This would be a 45-degree reference angle, which I would have gotten from 180 minus 135. And so this is 1 square root 2, and cosine in the third quadrant is negative. And so the cosine is negative 1 over the square root of 2. Cotangent of pi over 2, that's one of our quadrantal angles. And cotangent is cosine over sine. And so that would be 0 over 1. So the cotangent of pi over 2 would be 0. The tangent of pi over 2, therefore, would be undefined. And number 12, solve cosine theta equals negative 1 for theta in degrees. And whenever we have sine, cosine equal to 1, 0, or negative 1, it's a quadrantal angle. And for cosine, it's this quadrantal angle over here at pi. And so let's see. When we're not doing the inverse cosine, there's an infinite number of solutions, right? So the cosine is negative 1 at pi. And then it would also be negative 1 if I were to go a full revolution and then back to that. We can't just put n pi, because if I put n pi and I let n be 0, I'm actually over here. The cosine over here is 1. So what I have to put is that theta is pi plus 2n pi. So that I start here, that's where I'm starting, and then I go 1 revolution, then I go 2 revolutions. And if I go 0 revolutions, I'm here. Okay, so that's about the best I can explain that. 13, express the cosine of 170 degrees in terms of its reference angle. 170 degrees is going to be right close to that axis, right? Where this is 170, so this would be 10 in here, because this is 180. So therefore, in terms of its reference angle, the cosine in the second quadrant is negative. So we put negative cosine 10 degrees. Some of you on the quiz put the negative in front of the 10. And the cosine of negative 10, that would be this angle over here. That would be negative 10. So the negative goes in front, just to tell us that wherever this angle originated, or wherever this triangle originated from, it was either in the second or third quadrant because the cosine's negative. Okay. Let's see. For this, we got pi plus 2n pi. This is negative cosine 10 degrees. Then for number 14, it says that theta is a third quadrant angle. Draw a picture in the third quadrant. And that the sine of theta is 5 over 12. Okay. Find the values of the other 5 trigonometric functions. Questioning as whether or not I really wanted that to be 12 or if I really wanted it to be 13. But it is 12. So that means when I go to find x squared plus 25 equals 144. So x squared is 119. So x is the square root of 119. Okay. So that means that the cosine is the square root of 119 over 12, negative. The tangent is 5 over the square root of 119, and that's positive. The cosecant is negative 12/5. That's the reciprocal of the sine. The secant is negative 12 over the square root of 119. The cotangent is the square root of 119 over 5. So, whatever that's worth. Find tangent theta if secant theta is 5/3. So, and theta is a fourth quadrant angle. Down here in the fourth quadrant, and the secant, which is the reciprocal of the cosine. So that means the x value here is 3 and the r value is 5. I don't think I messed up on this one. Pythagorean theorem or 3, 4, 5 triangle. And we want to find the tangent of that. So the tangent of that is going to be negative 4/3. Tangent is y over x. So negative 4/3. Then we have find the exact value in radians, and these are the inverse functions. So there's going to be one answer. Okay. So number 16, we have the inverse sine of square root 3 over 2. So it's positive, which means I'm going to be in the first quadrant. This would be the square root of 3. This would be 2. This would be 1. That's a 60-degree angle. So my answer is pi over 3. Okay. 17 is the inverse sine of negative 1. Well, that's a quadrantal angle. It's going to be down here. This is positive 1. This is where the sine would be 0. Remember, this is pi over 2. This is 0. This is negative pi over 2. And so we have to say that our answer is negative pi over 2. Because 3 pi over 2 is not within the restricted domain. 18, cotangent, inverse cotangent of negative 1. And as said before, this is the one that seems to cause the trouble. Because with tangent and cotangent, we see 1 or negative 1. And we see 1 or negative 1 and we think quadrantal angle. And it's not. tangent and cotangent are 1 and -1 at the 45-degree angles. So again, the first thing I do is determine what quadrant I'm in. And because it's cotangent and it's negative, I'm in quadrant 4. And this would be 1, 1, square root 2, which means this is 45 degrees, which means my answer is -pi over 4. Then for number 19, we have the inverse secant of 2. So again, the first thing I think about is what quadrant. It's going to be quadrant 1. And it's the inverse secant. Secant is the reciprocal of the cosine. So this would be 2. This would be the one down here. And the square root of 3 would be over here. So that is a 60-degree angle. My answer here is pi over 3. Okay. Then we're graphing y equals negative cosine x, period 2 pi. The amplitude is 1. Even though there's a negative in front, amplitude is positive. The domain will be all real numbers, and the range will be -1 is less than or equal to x is less than or x. I did what you guys do. Y is less than or equal to 1. And I just know that already because I know what this graph is going to look like. I'm going to count by pi over 2. So there's pi, 2 pi, that's pi over 2, 3 pi over 2. And as I've said in class, you need to graph at least 2 full periods. It's usually this, it's not a problem. So we get the translations that we have a little bit of trouble like that. 3 pi over 2. So 1, -1. What the negative does out front, that cosine usually starts up here at 1 because the cosine of 0 is 1. The negative out front is going to make us start down here. We're still going to be 0 at pi over 2. At pi, we're usually -1. That negative out front is going to make it +1. And then we just have that pattern. This would be 0. This would be +1, 0, -1. So we have, that would be the graph of that. Okay. Period. That 2 is going to change the period. It's going to be, period's going to be 2 pi over 2 because it's 2 pi over b. B is 2. The period's going to be pi. The amplitude is going to be 3. Domain's still going to be all real numbers. The range, I'll have to wait for the graph to determine the range. That's the way I do it. So here's my graph. I'm going to count by pi over 4. 1, 2, 3, pi. 1, 2, 3, negative pi. Negative pi over 2, negative pi over 4, negative 3 pi over 4. Pi over 4, pi over 2, 3 pi over 2. If I graph this all the way from negative pi to pi, that's 2 full periods. And then I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. With this, I don't have to do like the parent function and then shift it, or I don't have to do a new set of axes because there's no translation. Okay, so I just start graphing. The sine of 0 is 0, and 0 times 3 is 0, so we're still going to start at 0. Pi over 4, the sine will be 1, because when I plug it in, I'll actually get pi over 2. Sine of pi over 2 is 1, and multiply by 3. And I guess I could have figured out that range without the graph. And then we would be back to 0 here. And screensaver on me. There we go. And we're back. Sorry. So anyway, we start at 0, and then at the next point, we'll be up at 3, and then we'll be back at 0, and then we'll be down at -3, and then back at 0. Going the other way, this will be at -3, 0, +3, 0. So looking something like this. Okay. So our range, I could do this without the graph. -3 less than or equal to y less than or equal to 3 would be our range. And that is it.